What's up, you guys? So we're going to talk about domains of functions, not specifically ranges, because again, this is an expansion off a session I had earlier with a student, a tutoring session, and I realized that many different types of, it's a pre-calculus class in a high school, and I realized that across districts that they seem to be on the same page with things, so I kind of want to go on specific to that agenda. So let's get started. So domain, what are we talking about? Domain, right? A domain of a function. Domain of function. Now, what are we talking about? First of all, it can be denotated, right, as d of f. You might see this in an exam, freak out, but now you know that's the domain. Now, what does it mean? Essentially, you're looking for x values, all x values, all. It's not an, it's al, l, a double l. All x values that define the function, or that make it defined. Right? For instance, we had a problem in one of the earlier videos, y equals to x squared minus 9, right? Well, if we're just trying to find a value for y, we could technically plug in any x value because it's a polynomial, and usually the main characteristic of a polynomial like this is that it works in that order where you can, all x values, it's all real numbers usually. You can use anything from negative infinity, right, to infinity and get a valid answer, right? Nothing undefined. Now, what are we talking about when we're saying undefined? Well, if you have a rational expression, say y equals to 1 over x minus 4, right? It's a different function. The difference here is that we are now including a fraction of some sort, right? Our rational expression, right? And what this means is that we have limitations and restrictions that we have to set for our x values, our domain, and then we can find those values that aren't allowed and aren't within the domain, and then form a domain around those values, which is usually easiest. So the domain is usually, you ask yourself, what values can I not use, and then everything else is your domain, right? This is fairly simple. Some of you know how to do this. Again, some students may run into a hassle. By the way, these are infinities. So 1 over x minus 4. So think about this. I'm going to go back to a specific rule. It's going way back, right? A is any number, arbitrary. We can set it to 1. We can set it to any valid number, not a variable, but a number, right? But over 0 is undefined, right? So you don't have a defined function if you have 0 in the denominator. However, I'm going to compare this to this. 0 over a, with a, any number, is 0. That's a defined function. You can have that. That's not a problem. 0 is a number. Valid answer. It's a definite answer. Or even if you get a negative answer, right? If you have, say, I don't know, if it ends up with any negative answer, it's still defined. Some people even confuse that end, where they think that negatives or negative numbers or negative values, right, negative outcomes, make the expression undefined. No, it's usually limited to certain aspects right here. When you have like 0 as a denominator, right? Another case is with square roots, and you'll see this often, right? We know that anything under that square root, that x has to be greater than or equal to 0, right? Because you cannot introduce a negative x, right? For instance, this is going to be review and reinforce a concept that many of you learned later in the course, right? Because this is going back. It's review for final. If you have -1, square root of -1, then you introduce imaginary numbers. Keep that in mind. That's a note. Keep that in mind. So you do have a restriction, and these is usually where you find the restrictions in rational expressions, square roots, and there's a variety of others, but these are usually most common, right? At least the ones I've seen so far with you guys' work. So again, we have here a rational expression. that means we have to find all x values that make this denominator 0, right? To find what x values we cannot use, and then kind of construct our domain around those values. So just simply take the denominator, set it equal to 0, because that's what you're trying to find. And then we have it x equals to 4, or x cannot equal to 4, right? Because if you place 4 in there, you get 0. So essentially, our domain of the function is what? It's negative infinity, because remember I said it's all other values that work, to 4, right? Union 4 to infinity. Sounds good, right? Now let me show you how this works and why this works. And I'm using these fairly simple expressions because I want to get into the conceptual understanding more so than the mechanical or strategic understanding. This is strategic, what we just did. You know, I tell you to set it equal to 4, and I tell you to solve, and that's usually what students learn in class. But I'm going to show you why I'm drawing other concepts. If I draw a number line right here, right? The x-axis, this is x, right? And I say, this is infinity, this is negative infinity, right? And I place negative 4, or 4 actually, right here, right? We know that we have said already that we can use all other values except 4, meaning that we can take from negative infinity and pick and choose and go, you know, picking any of these x values, right? And get all of them that approach 4, and that's why you circle it, because you don't include 4. Same thing with negative, positive infinity. You take positive infinity for the right, and you start picking x values, and you pick all x values, right? And then once you start approaching 4, you get really careful, and you only approach it, you don't get close. What do I mean by approach it? So I'm approaching 4 from the left, as you can see. I'm picking x values from the left and getting really close to 4. And I'm approaching 4 from the right also. I'm getting all x values from infinity and then bringing it closer to 4, right? Now, what does that mean? That means that I can pick a value of, say, 3.99999 and continue that forward. It's not strictly 4. Close to 4, proximal to 4, still not 4. And if I were to plug it in for x, I'd get a negative number and a negative expression. And remember I said negative outcome is still defined. You would have a negative number. That's fine. Now 4 from the right, I can pick 4.000000001. Because of that, it's not strictly 4. I didn't choose 4. I chose something very approximate close and really close to 4. That means if I were to become microscopic and then jump on that number line, there's a tiny interval where you can see a gap between this number what I just chose as my x value, 4.00001, you know, multiple zeros and 1, and 4. You can see a tiny gap. It hasn't hit it. And I can choose that and plug it in here and get a positive number, right? Okay, so that's what it means. The expression is still defined, but we haven't included 4. By the way, I'm going to erase this. Keep this stuff in mind, right? These are the common things and conventional, I guess you could say, conventional details that you might come across, or elements that you might come across most often. All right, so let me continue this onward. All right. So we talked about that. We said 1 over x minus 4, right? Now what if I said this is a new example, x squared minus 9, right? What about this one, right? We have to find the domain. Again, rational expression, that's what you have to consider. Then you have to think, well, rational expressions are undefined when the denominator is 0. So then go ahead and set it equal to 0 again, right? Equals to 0. And you can factor this out, x minus 3, right? X plus 3. This is following that a squared minus b squared rule. Wait, a squared. Yeah. Because then this becomes a minus b, a plus b, right? So you can go ahead, and this is like, I guess, a conventional way or standard that you guys are supposed to memorize. This is what this is, and then we already said that set that equal to 0. This equals to this right here. Set it equal to 0, and we know that our x values that we cannot use cannot equal to x minus 3 equals to 0 is set solve for x, you get 3 and negative 3, right, for both of them. That means that we have on that number line x negative infinity, we have two spots where we have to approach but not include, right? Because if we include it, then it makes this value 0, or the denominator 0. And I won't even throw 0 there. 0, actual 0, midline is here somewhere. So we can take all values, right? Get approximate close to negative 3. Approach it, right? Circle. And we could choose anything in between, right? Approach it, approach 3, and then continue on to infinity. Think about you actually physically picking these x values, like, I don't know, Mario, Mario Brothers, and or like some video game character just going out there, right? And they're picking these things out like mushrooms, right? And then using it to your advantage and whatnot. I always imagine that kind of thing, and that's always helped me, is putting it into the context of I used to be a video gamer. That's just the way I do things. I guess make it a little bit more appealing to you. Maybe you can think of it in that aspect, but you know, yeah. So anyways, I digress. So yeah, that's our domain. Essentially, is then we can use all x values going from negative infinity to 3, right? Union, and then we said from negative 3, we haven't included it, and again, that's what these parentheses stand for. They're not brackets. Remember, brackets include that choice, but you're not doing that in this instance. So we can approach negative 3 to 3, right? Because we have that from here to here, and then union, and then we have another interval. So you separate these into 3 intervals, and you can see that visually that there's 3 intervals right here, and you need to label that from 3 to infinity. Now, I know some teachers require these to be written in a different format. I can't remember the exact format, but it all works the same. Just to understand it is imperative at this point. All right. What about another instance? What about then 1 over root x? Right, now you're considering a rational expression, the limitations on that, which means 0 is undefined, or the denominator is the expression is undefined when the denominator is 0, right? And you're also considering the restrictions set on this root value. By the way, always include that bracket to extend it beyond whatever's inside. Okay, I have a bad habit with that. I get a lot of points marked off because of that. Anyways, so first of all, you have to think, okay, well, root x alone has a restriction. And remember, we said you can't have anything negative. You can have 0 because, well, I'm going to set this x. Here, let me put this. X should be greater than or equal to 0, right? Because you can plug 0 in. And by the way, square root of 0 is 0. It's an actual number. Remember, 0 is fine. You can use that. No problem in getting the outcome of 0. That's not 10. That is 0. 0, right? So x has to be greater than or equal to 0, right? So your domain for this function alone would be 0 to infinity, right? Because you can use any x value going from 0 to infinity as long as it's positive or 0. And another thing is 0 is neutral. It's not positive or negative, so you can say 0 or positive, right? Now, in this instance, we have that in the denominator, but if we do plug in 0 and we include 0 with the root value, because look, now it's assuming the position as a denominator. Now, if we do include 0, unfortunately, we're going to get this expression, which includes the root value as a denominator. It's going to be undefined, right? So we don't want that. So we have to even further restrict ourselves and say, well, this guy has limitations. I'm sorry. Could be x has to be greater than 0, right? Has to be positive. In this instance, positive because of the root, right? But cannot include 0. That's why we took away that small that underscore, right? Because we're no longer including 0, and say, well, you can approach 0, still get a number, but the minute that we actually include 0, this entire thing is undefined, right? So our Let me go back to this. I seen a mistake. You include a bracket, right? Because you include 0. Bracket include 0. In this case, you don't. Right? Okay, I think I went over on time. Something simple. I'm going to continue with this. I don't want to bore you guys too much. Math could be tedious, and it could be, yeah, it's not a pretty thing sometimes for some. But again, I'm trying to go over these concepts and trying to enlighten these things and trying to bring out, or draw out those specific areas where students really have trouble understanding. Like a lot of them don't know that root 0 equals 0, and that's an actual definition, defined expression, things like that. I really want to emphasize those things because it makes learning these so much better. Okay, I'm gonna stop here and I'll post this video and continue with more. Thank you.